Hello students, welcome to my YouTube channel Chemistry of IIT. Today in this video I am going to start the another new one important name reaction. It's not name reaction, it is depend on a reagent, that is name reagent. This is so much important for your exam. Grignard reagent. So Grignard reagent. What is Grignard reagent? Grignard reagent is a simply magnesium salt of alkyl halide. Means let's suppose this is the R, any alkyl group is attached with magnesium, which is attached with another halide group. This is the Grignard reagent. Here X can be chlorine, bromine, sometimes iodine also, but mostly bromine is there. Now how this is prepared? Here first alkyl halides, let's suppose RBr, is reacted with magnesium in presence of dry ether. So it gives Grignard reagent, which is RMgBr. This is the reaction for preparation of Grignard reagent. Now how this react with and which type of compound? So now we will see now. Firstly, here if we write the structure of Grignard reagent in the charge from them, minus negative charge on alkyl group, positive charge on magnesium, and Br is attached. So how this is look like? So this R minus is sometimes act as a base, preferentially act as a base, and then it will act as a nucleophile. If in the reaction mixture or in the reactant acidic proton is there, then it will, acid base reaction will be happen. Otherwise, if there is no any acidic proton, then it will act as a nucleophile. Now you will see how when it will act as a base and when it will act as a nucleophile. Now first we will see acid base reaction of Grignard reagent. And remember please, anytime if the acid base reaction will happen, then prepare to the acid base reaction before elimination and nucleophilic addition substitution reaction. Please prepare acid base reaction. Now first you will see acid base reaction of Grignard reagent. So this type of acid will react with the Grignard reagent. First, if the nitroalkane means let's suppose CH3 CH2 NO2, here two protons are here. This proton is acidic. How acidic? How it is acidic? Because this is a strong electron withdrawing group. Let's suppose proton is removed out from here. What will form? CH3 CH minus N double bond O, O minus, plus here. This negative charge is well stabilized by that nitro group. So it is a acidic proton. And if we react nitroalkane with RMgX, acid base reaction will happen. And what will be the product? CH3 CH, here R, here NO2 plus, sorry, it is acid base reaction, CH3 CH NO2, here MgX plus R and H. This will be the major product of this reaction. Now second, again another compound where it has actually base. Another, let's suppose this is nitroalkane, then another one is the active methylene compound. What is active methylene compound? Here is I am giving one example. This is the methylene. And why this is active? Because here two protons are there. If the proton is removed out from here, this negative charge will be well stabilized by that carbonyl group also and that carbonyl group also. Therefore, it is called as a active methane compound, and this is the very acidic proton. If we react with it RMJX, what will form? Double bond O, double bond O. Here, what will attach? MgX plus RH. So remember, active methane compound will also act as an acid for Grignard reagent. Means Grignard reagent will react with a base. Now next one. Again, which type of compound Grignard reagent will act as a base? Terminal alkynes. What? Terminal alkyne, not alkene, alkyne. Let's suppose I am taking the example C triple bond CH. If we react with it a RMGX, which is the acidic proton? This. Why this is acidic proton? Because this carbon is so much electronegative, which is sp hybridizer, and you sorry, terminal alkyne. Let's suppose this is the terminal alkyne. I am taking that one, and if we react with it RMGS, that is Grignard reagent. Now, why? How this is the acidic? This is the acidic proton, acidic proton, and how this one is acidic? Because this carbon is highly electronegative. Why highly electronegative? Because it is sp hybridized, and I hope you will know that why this is. If the S character is high, then it is a very electronegative, and the unnegative charges will stabilize by electronegative atom. Similarly, like oxygen, nitrogen also. So here, let's suppose R dash, this negative charge. This negative charge is on that electronegative carbon, therefore it is stabilized. So if we react with the Grignard reagent, what will form? C triple bond C MgX plus RH. How this is the, that's how the Grignard reagent with the lactate base is a terminal alkyl. Now next one is D. Next one, the Grignard reagent will act as a base. That compound R will be R alcohol, that is ROH, or let's suppose water also. If we react RMGX, why this is acidic? Because if proton is removed out from alcohol, negative charge will be on oxygen, which is very electronegative and which is well stabilized because negative charge is on electronegative atom. So what will form? ROMgX plus RH. So how this is the, how this way the Grignard reagent will act as a base is the alcohol also. Now next one is nitrogen, like amide also. If we react RMGX, what will form? RC double bond ONH MgX plus R, sorry, amide RC double bond ONH2. If we react with RMGX, it will form RC double bond ONH MgX and RH. Now the next one is next compound that will react with the Grignard reagent as a acid base reaction with thiol, means let's suppose RSH. If we add RMGX, it will form as a product as plus RH. And even also, if secondary amine or primary amine, it will also react as a acid base reaction. So what will form? RR here MgX plus RH. sorry, this is R dash. This R is always from the Grignard reagent. Remember that one is also. Now the next one is the compounds that will react with Grignard reagent as a acid base reaction, that are QC aromatic. QUASI. QC aromatic. QC aromatic means the compound that will that are not aromatic, but after removing the proton they that will make aromatic. So which type of compound? Suppose this is the compound. If you see here, this is not a aromatic 4n pi electron system, that is it is non-aromatic because this is the sp. Neither anti-aromatic nor aromatic, this is non-aromatic. If we why this is the acidic proton? This is the acidic proton. Why this one? Because if you remove one proton from here, what will form? Now see here, every carbon is sp2 hybridized, 6 pi electrons are here, then it becomes aromatic and which is highly stable. So therefore this negative charge is very stable, so this proton is as a acidic proton. So if you react it with a Grignard reagent, so what will form? Here mgx plus RH. So if this type of compound will be given in the question, then do the acid base reaction firstly, then go for the nucleophilic addition reaction, that is nucleophilic attack of a Grignard reagent. Now I will give one example there. Please tell me quickly, if this is the compound and I added a RMGX, how this will prepare, how this will react? This R minus will attack or this carbon or see carefully here, this is the active methylene compound, so this will react as a base with that compound and form RH. Now comes to the nucleophilic attack of Grignard reagent. So on which type of compound Grignard reagent will attack as a nucleophile? The compounds which are electron deficient having no acidic proton. So here carbonyl group, majorly aldehyde, ketone, acyl chlorides, esters also, acids also, amides. But we will see later the how the reactivity of Grignard reagent with different carbonyl compounds. Firstly, let's suppose I take a formaldehyde, then aldehyde, then ketone. If we react with a RMGX, what it will make? If we see here is no any acidic proton, so this will negative, positive, not negative, total not negative, delta positive and delta negative. That is partial negative, partial positive charge. So this nucleophile will attack the carbon which is electron deficient. I hope you will know that this carbon, why this carbon is electron deficient. This will attack on that carbon, this bond will open, so what will form? HCH, here O minus is formed, here R, and this negative charge. What is the counter ion of that negative charge? MgX. Similarly here also RCH, ROMgX. Similarly here also CROMgX R. Now further, if I added here water, here I added water, water. Why I have not here with RMGX? plus water, because this will react to the acid base and reaction will not proceed as a nucleophilic attack. Therefore, please always remember, if reaction is given in the exam, this reagent should be written like as a first RMGX and second H2O. They written like that. Why not? Let's suppose RMGX and H2O. They are not writing like that. Meaning of that is, in at a time we added a RMGX as well as water, and here the meaning of that is, firstly we added RGMGX, Grignard reagent. It will react with the carbon compound, it will form this type of compound, and after if we added water, then what will form we will see now. Here if we added here water, what will happen? Hydrolysis of that bond will happen, and here alcohol, sorry, alcohol. So this is the CH2OH primary alcohol from here, RCRH secondary, this is primary, secondary, and from here RCRROH, this is the tertiary alcohol will be formed. So this one is important because this is little much confusion. If we add it at a time water and RMGI, this product will not form. So always write like that, not like that. And again, one thing I want to tell is that during the preparation of Grignard reagent, why we it is carried out in a dry ether. Why in dry ether? Because ether is inactive, that is unreactive, inert for that REMGX, that is Grignard reagent. If we do in water solvent, then Grignard reagent will not form. If we do it, that's why we have to do in dry ether. And always remember that in also here also, if we added here RMGX, they are not writing like that only RMGX, they are writing dry ether. Everywhere dry ether, dry ether, dry ether. Here also dry, here also dry ether, and then water is added for hydrolysis. So this is also important. Why dry ether is used? Because it is unreactive with inert with Grignard reagent. So dry ether is used. Now we are going to learn the nucleophilic addition reaction followed by elimination. How this is? Let's suppose I have taken acyl chloride. What is the structure of acyl chloride? This is the structure of acyl chloride. If I added Grignard reagent and dry ether in a solvent, dry ether, here no any acidic proton, so this will attack on that carbon carbon. This bond will open, comes back, and this chlorine is a very good living group. So therefore this chlorine will leave out, and what will form? RC double bond OR plus MgHCl. Now one question will be comes in your mind, that in the nucleophilic addition reaction, if I take a aldehyde or ketone, let's suppose CH3 CH2 C double bond O, whatever it will be, HClHr. Our question is that here is the proton, here is the two protons are there. If we added RMGX, why it is not make a acid base reaction with that proton? It is also acidic. How this is acidic? This is well stabilized by also that carbon carbon. But you will see in aldol condensation we are using NaOH as a base, and this is acidic proton is taken by that base. But RMGX is not that like very strong acid like NaOH. So here this is not a strong, not so much strong base, therefore it will not, and this is not so much acidic also like nitro or active methyl compound. So therefore it will not exert acidic proton for particularly Grignard reagent. So Here it will act as a nucleophile and attack on a carbon carbon. So this is the one doubt maybe comes in our mind that now in nucleophilic addition elimination reaction which type of compound will be used means where it is applicable in which type of compound. First one is, let's suppose I have taken this. Now X is equal to, it will be halogen, chlorine, bromine, iodine. It will be O R dash means ester. If X is equal to O R, what will form ester? Sometimes O C double bond O R. Here O C double bond O R means what? It will be anhydride. Sometimes amide. This is also good living group. So these are the compounds where the addition elimination reaction with Grignard reagent will happen. Now again one question will becomes in your mind that let's suppose I have taken that, let's suppose Br is here, or another one, let's suppose I have taken that anhydride. Here not oxygen, let's suppose here CH3 or R, suppose R, I have taken R. Now if I react that anhydride with a Grignard reagent, so what will happen in dry ether? This negative charge, will act as a nucleophile and this bond will open, comes back, and this will leaves out. So what will form? C double bond O R MgX, here O C double bond O R. This bond is a Mg. Now you will say again it will act as a nucleophile because we are not using, if one not one, if in the reaction one equivalent is not mentioned, they will mention that RMGX in excess. So what will happen? This RMGX again act as a nucleophile and attack on that carbon carbon. This bond will open. Now what will form? RCO minus MgX. Here R, here R. This will form. Now there will not any electron diffusion, so it will not attack on nucleophile, attack as a nucleophile. So now next water will be added, and what will be the product? R tertiary alcohol. So if we use this type of compound, then tertiary alcohol will be formed. If Grignard reagent is used, this tertiary alcohol will be formed if we have, if Grignard reagent is used in excess, not in one equivalent. Now we will see the in nucleophilic attack of Grignard reagent. The reactivity of different carbonyl group means, first let's suppose we have taken acyl chloride. Next one anhydride R C double bond O C double bond O R. Next one we have taken that formaldehyde C double bond O H. Next one we have taken that ketone C double bond O H. Next one ester R C double bond O O R. Next one we have taken suppose amide R C double bond O N R 2. Now what is the reactivity of Grignard reagent with different types of a compound? Now tell me, Grignard reagent acts as a nucleophile. Yes, is it clear? It acts as a nucleophile. It requires a electrophiles, means Grignard reagent requires a strong electrophile. So among these, which is a strong electrophile? Obviously this. Why this is a strong electrophile? Because I hope you know that, because all halogens negative minus I effect is stronger than plus m. Minus I effect of halogens is stronger than minus m. So it pulls electron density towards itself, and this is also pulls electron density towards itself. So this is making so much electron deficient. But if you see here in amide, this is the not so much electron negative atom. It has a lone pair which can make, it will donate electron lone pair to here, which will make less electron deficient to that carbonyl carbon. If you see here, lone, this is electronegative atom, but it has also a lone pair. This lone pair will conjugated with that carbonyl carbon, and this electronegative atom will pull electron density towards itself, so it is also electron deficient. Here among these two, now these are the electronegative group, therefore it will become so much electron deficient. Here it is no any electron don't electron withdrawing group, electron negative atom. But among these two, here R group always prefer plus I effect, that is plus inductive effect. It will make little much less electron, makes little much more electron rich than this one. So this one this will become more electron deficient than this. And here also it has a lone pair which will donate lone pair towards itself. It will also make less electron, means little much more electron rich. So among these, which one is more electron deficient? This. So order of the electron deficiency of carbonyl carbon is this. So Grignard reagent will also react in that order with, first will acyl chloride, then anhydride, then aldehyde, then ketone, then ester, and last one is amide. So this is the order of reactivity of that compound with the Grignard reagent. So now I will give one question depend on that reactivity. Let's suppose I have take one example, question 1. Here OH, let's suppose here chloride, here suppose ketone, here suppose aldehyde. If I use the RMGX 1 in dry ether, this RMGX is a 1 equivalent. Then preferentially here what will the happen? What will happen? Let's see. What will happen? This, here is no any acidic proton. If you see here, which one is acidic proton? This one. See, this is so much complication. This is the acidic proton. Why? I already told that alcoholic is a acidic for Grignard reagent, and again this will form a phenoxide ion, which is very well stabilized by that benzene ring. So if I use one equivalent, then what will form? One equivalent RMGX. So product is formed is that OMGX, and another group will be remains same. This will form. And what is the another byproduct is RH. Now if I increase let's suppose I have taken two equivalent, this will react with one equivalent, another react equivalent, that is RMG, let's suppose X. This will react with preferentially which of carbonyl group among these, this one or this one. I have already told that which will more reactive. This is obviously this will attack on that carbonyl carbon. This bond will open, comes back, and this chlorine group leaves out. So what will form? Here OMGX, here double bond OR, here H, here R. Now here, if I added another RMG, Grignard, another equivalent of Grignard reagent, then it will react with which of the carbonyl group? Now among these, this is ketone, and this is aldehyde. Therefore, it will preferentially react with this carbon and carbon. If I added another next one electron equivalent of Grignard reagent, it will react with this one or this one because both are same. So please remember the reactivity of group also, because it question will be asked depend on equivalent of Grignard reagent. If I added two equivalent, then product will be formed is that like that, two equivalent. So we will how this is being makes you will make mistake, how this is how you will make mistake, this RMG group will attack on that carbonyl carbon. But if you see carefully, here is the one acidic proton, so acid base reaction will be preferred. Now we will see the reaction of Grignard reagent with cyanide, how the Grignard reagent will react with cyanide group. Let's suppose I have taken this cyanide, added RMGX, dry ether. How this will react? Here is no acidic proton. You will see. Let's suppose I have taken CH3, CH2, C triple bond C. But this cyanide group is not as much as electron withdrawing like a nitro group. So this proton is not so much acidic like in nitro compound. So here what will happen? This RMGX will act as a nucleophile, and this attack on that carbonyl, not carbonyl, the cyanide carbon, which is also so much electron deficient. So it will form RC, here R double bond N, MgX. This will form. Now next step. Next, if we added water, so what will form? This look like what, imine formation. So we have already seen in the previous some video that hydrolysis of imine forms what, ketone. Obviously this will, two bonds will be replaced by oxygen. So what will form, RCR double bond O. Let me explaining the mechanism of that. What is that? RC double bond O N MgX, here R, water is added, this will act as a nucleophile, this bond will open, and what will form, RCO MgX, here H, here R, here OH. Now this bond will come back, the nitrogen is there, and this nitrogen will be protoned and this will lose out. So C double bond O R. How this is formed? Now you will see that here is the carbonyl carbon, Grignard reagent is there. But if you see, now we have added water. So what this Grignard reagent? Let's see. I will explain in detail slowly. First, we have added Grignard reagent. It reacts with cyanide to form that imine formation. Now then, after that, added a water. It will make hydrolysis of imine. It will form ketone. Now you will see here is the carbonyl carbon, Grignard reagent in present. But if you see, if you see this Grignard now in the reaction mixture, water is also available, Grignard reagent is also available. So these two form acid base reaction, and this Grignard reagent will becomes inactive. So now there is no any Grignard reagent molecule present in the reaction mixture, and this will remains as like ketone. So if we react cyanide with the Grignard reagent, it will form a ketone. Now we are going to see the reaction of Grignard reagent with oxide and sulfides. Means let's suppose RMGX, how it will react with a carbon dioxide. What is the structure of carbon dioxide? This carbon is electron deficient. This will act as a nucleophile, attack on that carbon carbon. What will form? C double bond O, O minus, here R, MgX. Sorry. Here R and here MgX. Now if we added water, what will form? C double bond O, OH and R. So if you react with a carbon dioxide with Grignard reagent, it will give us a carboxylic acid. If we react RMgX with the sulfur dioxide, S double bond O is the similarly like carbon dioxide, it will also form S double bond O sulfonic acid. Now, now if we react RMgX with a sulfur trioxide, what that means SO3. What is the sulfur trioxide? Triple bond O, triple bond O, triple bond O. It will also react with like above Rmg minus. It will act on sulfur. This bond will open. So yes, double bond O, double bond O. Here R and here OH plus MgX and OH. First step, then next here I have to mention that water is added in the next step. So this will form. Now I have explained so much detail, so much explanation of that Grignard reagent, reactivity of Grignard reagent with different compounds, its acid-base reaction, nucleophilic attack. But even you have made notes depend on that. But if you not solve the previous year question, then you don't will not get the idea how the question will be asked in your exam, and you should have to make the approach of the question, how to solve the question. So you should have to practice the previous year question and some, if you complete a previous year, then practice another question in test also. So now I'm going to discuss the previous year question depend on that Grignard reagent. Here the question is that reaction of that cyanide, which is cyanide, ethyl cyanide with Grignard reagent, it will be A, which on hydrolysis give B, which on with ZNAGHCl. What is it? Which reagent is it? We have already seen in previous one video. I don't remember the number of that video, but it is a Clemmensen reduction reaction. Clemmensen reduction reaction is used for what? Ketone or aldehyde. It will give simply alkene. Now this is the Clemmensen reduction. It is a combination of Grignard reagent and Clemmensen reduction. What is form? Here cyanide is there, Grignard reagent is there. I have told you already, explained that how Grignard reagent will react with cyanide. Let's see how. CH2 C triple bond N, CH3 minus MgBr. It will attack on that carbon carbon. This bond will open. What will form? CH3 CH2 C CH3 double bond N MgBr. Then water is added. Water means what? Acidic hydrolysis. You can say also. H3O plus means acidic hydrolysis. What will form? CH3 CH2C double bond O CH3. Now Clemmensen reduction ZNHG. What will form? Ketone to alkane simply. So what will be the our product? CH2 CH methane ethane propane butane should be. And here the in the option A is given that product. So option A is correct of that question. So this is the question depend on that Grignard reagent which was asked in JEE mains 2022. So this is enough for that Grignard reagent. This is little much vast topic and also important for your exam also. I hope you have will understand that explanation of the Grignard reagent. Practice it again and again. Make your own trick, because if I made my trick, then it will be hard for you. So always make your own trick. So it will easy to remember for you. So thank you for guys. This is enough for today. I will continue the next name reaction in the next video. Bye bye. Happy learning.